Hello everyone. Today I am going to tell about complement of a set with examples, properties and solutions of exercise 1.5 from Ncert class 11. A complement of a set is a set which contains only the universal set elements but which does not contain the elements of that set. So the complement of a set A is the difference of sets universal set and the set A, which belongs to U but which does not belongs to A. So here the complement of a set is a set which contains the only elements of the universal set but which does not contain the elements of that set. And it is denoted by the symbol here like this. And the complement of a set which we show like this. For example, if you take a set which elements of 2, 4, 6 and the universal set contains always the elements of the other related sets also. So here the universal set is 2, 4, 6, 8, 10, 12. Then the complement of the set A is equal to the difference of these two sets. So here U minus A. So here U minus A means we have to write only the elements of the universal set and we have to exclude the elements of the set A. So here if you exclude the elements of the set A, those are 2, 4, 6 and here the complement of set A is equal to 8, 10, 12. These are the elements of the universal set which does not contain the elements of the set A. And next example is U is equal to AEIOU and A is equal to AIU. Then the complement of set A is equal to, you have to eliminate these elements AIU. Then the remaining elements of universal set are EO. So this is the complement of set A. And if you see here, always the set is a subset of the universal set because all the elements of the related sets are in the universal set also. So if A is subset of U, then here the complement of set A is also the subset of U because the remaining elements also that is the complement of set A, those are also belongs to U only. So if A is subset of U, then A the complements of set A is also subset of U. And if you show the complement of a set in a set builder form, you have to write like this: X such that X belongs to U, but and X does not belongs to A. So X always belongs to universal set, but in that set, the elements of A are not in U. So this is the complement of set A. And we can represent by Venn diagram the complement of set A. We can represent by Venn diagram like this. If you take A is equal to 1, 2 and U is equal to 1, 2, 3, 4, then complement of set A is equal to U minus A. You have to remove these elements. Then those are 3, 4. These are the complement of set A. If you see here, this is the set A which contains the elements 1, 2 and this is the universal set. And the complement of set A which does not belongs to the elements of A. So you have to show here itself. This is the complement of set A which contains the elements 3, 4. You can see here. These are some properties of complement set. The first one is complement loss. If you take universal set as 1, 2, 3, 4, 5, 6 and A is equal to 1, 2, 3, we know that all the elements of A are in U also. And the complement of set A is equal to U minus A, the difference of these two sets, that is equal to 4, 5, 6. You have to remove the elements of A. So those are 4, 5, 6. And if you union the set A and the complement of set A, that is equal to, you have to write all the elements of A and all the elements of the complement of set A. Those are 4, 5, 6. So 1, 2, 3, 4, 5, 6. If you see here, 1, 2, 3, 4, 5, 6 are nothing but the universal set elements. So that is equal to U. Therefore, the union of A and the complement of set A is equal to universal set. And if you intersect A and the complement of A, then you can see here there are no common elements for these two sets. So here there are no elements, that means it is an empty set. So if you intersect the set and the complement of set, then you will get an empty set. You can see here, these are called complement loss. And next one, De Morgan's loss. if you take any two sets A, B like this, and U contains always the elements of A and B, and the extra elements are 3 and 5 here. 1, 2, 4, 6 are there here, and 3, 5 extra elements of universal set. And if you see in the first case, if you find out the complement of A, that is equal to U minus A, the difference of universal set in A, that is equal to 3, 4, 5, 6, excluding the elements 1, 2, you have to write the remaining elements of U. Those are 3, 4, 5, 6. And the complement of B also, U minus B. You have to exclude 1, 2, 4, 6. The remaining are 3, 5. And if you intersect these two complements of these two sets, then you will get here the common elements are 3, 5. So here the intersection of the complements of these two sets is 3, 5. And if you union A and B sets, then you will get 1, 2, 4, 6. You have to write all the elements here. And if you find out the complement of this A union B, then that is U minus A union B. So you have to remove the elements of A union B from universal set. Those are 1, 2, 4, 6. So 1, 2, 4, 6. So 1, 2, 4, 6. Then the remaining are 3, 5. So these are the elements of the complement of A union B. So if you see here, these two sets are same. So the complement of the union of any two sets is equal to the intersection of the complement, its complements, the set's complements. You can see here, this one. So the complement of A union B is equal to the intersection of A, the complement of A and the intersection of the complement of B, intersection of the complement of A and complement of B. Therefore, the complement of the union of two sets is the intersection of their complements. And if you see in the second case, the same sets, if you take here, then if you find out the intersection of A and B, the common elements are 1, 2. So right here, and the complement of A intersection B is equal to, you have to take out 1, 2 from this set, then 3, 4, 5, 6. So right here, and if you union the complements of A and B, then from this you can see here, these two, if you union 3, 4, 5, 6. So these are the elements. So you can write here 3, 4, 5, 6. And if you see, these two sets are equal. Therefore, the complement of the intersection of any two sets is equal to the union of their complements. So this is second one. So these are called the De Morgan's laws. So you can write here, that's two laws here like this. You have to remember these laws. This is third law, law of double complementation. So if you complement the complement of set A, that is equal to the set itself. So if you see this example, A is equal to 1, 2 and U is equal to 1, 2, 3, 4. The complement of A is equal to, if you take out these elements, say 1, 2, then the remaining are 3, 4. And if you complement again this complement of set A, then double complementation of this set, that is equal to U minus the complement of set A. That is equal to U, universal set is 1, 2, 3, 4 minus this set is 3, 4. So if you take out these elements 3, 4, then those elements are 1, 2. That is equal to A. 1, 2 are the elements of A set. Therefore, the complement of any set is equal to the set itself. So this you can write in a set builder form like this. X does not, here X belongs to U and X does not belongs to the complement of set A in this case. And if you represent this by Venn diagram, you can show like this. This is universal set, and here the complement of A is nothing but the set itself. So you have to show this set, that is that contains A elements 1, 2. This is the universal set, and this is the complement of set A. Those are the elements of 3, 4 here, and this is the complement of set A. And next one is laws of empty set and universal set. If you take universal set as 1, 2, 3, 4, 5, 6, and an empty set, we know that there are no elements. So the complement of an empty set is equal to universal set minus an empty set. So the difference of these two sets, and that is nothing but the universal set itself, because in an empty set there are no elements. So you have to write the elements of universal set only. So this is nothing but the universal set. Therefore, the complement of any empty set is equal to the universal set. And similarly, if you complement the universal set, that is an empty set. U minus U, that is an empty set. So the complement of an empty set is universal set, and the complement of a universal set is an empty set. Now I am going to tell the solutions of exercise 1.5 from Ncert. This is first question. Here the universal set is given and the three sets are given A, B, C, and you have to find these values here. So first write the given sets here. This is universal set and A, B, C. And first one is we have to find the complement of A. So that is the difference of universal set and set A. That is equal to, you have to exclude the elements of A from the universal set. So those are 1, 2, 3, 4. So the remaining are 5, 6, 7, 8, 9. And next one is complement of B. You have to find the difference of universal set and B. So you have to exclude these elements. 2, 4, 6, 8. Remaining elements you have to write here. So those are 1, 3, 5, 7, 9. And next one is you have to find here. You have to find A, the complement of A union C. We know that the complement of A union C is equal to intersection of their complements. So intersection of their complements, we know that the complement of A, and we have to find the complement of C here. So first to find the complement of C, you have to exclude the elements of C. So here only 5 is there. So the remaining elements you have to write 1, 2, 3, 4, 6, 7, 8, 9. This is the complement of C. Now A union C, the complement of A union C is equal to the intersection of their complements. So A and C, their complements, the sets are A and C. So their complements here are 5, 6, 7, 8, 9, and here 1, 2, 3, 4, 6, 7, 8, 9. So the intersection of these two sets is, you have to check the common elements here 6, 7, 8, 9. 6, 7, 8, 9. So write here 6, 7, 8, 9. So here the complement of A union C is equal to 6, 7, 8, 9. Next one, you have to find the complement of A union B. So you have to find a complement of A union B is equal to the intersection of their complements. So here intersection of these two sets complements. So you have to check the common elements here 5, 7, and 9. So you have to write 5, 7, 9 here. And next one is complement of A, that is equal to the set itself. So that is equal to the elements of the set A is equal to 1, 2, 3, 4. And next one is the difference of the complement of the difference of B and C. First to find the difference of B and C. So here B and C, here you have to check any common elements. Here no. So you have to write only B elements 2, 4, 6, 8. Now the complement of B minus C is equal to, you have to check with universal set. So any common 2, 4, 6, 8. Excluding these elements, you have to write the remaining. Those are 1, 3, 5, 7, 9. Like this, you have to find all these values. And next question is, here also U is given and you have to find the complements of the following sets A, B, C, D. There are 4 sets are given. You have to find the complements of all these sets by using this universal set. So this is also similar to the previous one. You have to find like this. This is the solution. This is third question. Taking the set of natural numbers as the universal set, write down the complements of the following sets. So here the universal set contains all the natural numbers. Those are 1, 2, 3, 4, 5, 6, 7, etc. These are called natural numbers. So the universal set is nothing but the natural numbers. And here some sets are given. You have to find the complements of the sets. So the first one is X such that X is an even natural number. We know that even natural numbers are even numbers. Those are divisible by 2. So those are 2, 4, 6, 8, etc. And you have to exclude these even natural numbers from the universal set, then you will get the complement of this set. Therefore, the complement of set A is equal to the difference of universal set and A is equal to, if you exclude these numbers from this set, then the remaining are 1, 3, 5, 7, etc. These are odd natural numbers. That is equal to x such that x is an odd natural number. So the complement of even natural numbers is the odd natural numbers. Similarly, the second question, x such that x is an odd natural number. Those are 1, 3, 5, 7, etc. So the complement of this set is, if you exclude odd numbers, then you will get the even numbers. So 2, 4, 6, 8, etc. That is, x is an even natural number. This is the complement of the set odd natural numbers. And third one, x such that x is a positive multiple of 3. So positive number as well as it is a multiple of 3. Multiples of 3 are 3 into 1, 3 into 2, 3 into 3, etc. These are called multiples of 3. So those are 3, 6, 9, 12, etc. If you exclude these numbers, you can see here 1, 2, 4, 5, 7, 8, etc. So from this set, you don't find any multiples of 3 for the complement of this set. So the complement of this set is equal to 1, 2, 4, 5, 7, 8. You have to exclude the multiples of 3. That you can write like this, x such that x belongs to capital N, because the universal set always contains the natural numbers. X belongs to capital N and x is not a multiple of 3, because here the multiples of 3 are not in this set, in the complement set. And next one is x such that x is a prime number. We know that the prime numbers have only two factors, the number and the 1 itself. For example, 2, the factors are 1, 2, and 3, the factors are 1, 3. And composite numbers are the numbers which has more than 2 factors. For example, 4, 6, 8, all these numbers are composite numbers. And 1 is neither prime nor composite. So here A is equal to x such that x is a prime number. So those are 2, 3, 5, 7, 11, etc. If you exclude these prime numbers from this set, universal set, then you can write the complement of set A is equal to 1, 4, 6, 8, 9. So if you see here, all these numbers are composite numbers. From 4 to all the numbers are composite numbers. But 1 is neither prime nor composite. So you have to write like this, x such that x is equal to 1 and x is a composite number. So the prime numbers, the complement of the prime numbers is x is equal to 1 and x is a composite number. And next one, x is a natural number divisible by 3 and 5. So the number which is divisible by 3 and 5 is nothing but 3 into 5, that is 15. So multiples of 15. If you observe all these numbers, 15, 30, 45, all these numbers are divisible by 3 and as well as 5 also. So these are the numbers. So if you exclude from the universal set these numbers, 15, 30, 45 like this, the complement of this set is equal to x such that x is a natural number which is not divisible by 3 and 5. So if you exclude all the numbers which are not divisible by 3 and 5. And next one is x is a perfect square. So we know that the perfect squares are 2 square, 3 square, 4 square, 5 square. Those numbers are 4, 9. 2 square is 4, 3 square is 9, 4 square is 16, 25 like this. These are called perfect square numbers or square numbers. So if you exclude these numbers from the universal set, then you will get the complement of set A is equal to x is a natural number, because the universal set contains all the natural numbers and not a perfect square, because you are excluding the perfect square numbers, so not a perfect square. For the complement of that set, not a perfect square. And next one is perfect cube. X is a perfect cube. Perfect cube means the numbers are 2 cube, 3 cube, 4 cube. All these numbers are called cube numbers, perfect cube numbers. 8, 27, 64, 125. These are perfect cube numbers. If you exclude from this set, universal set, then the complement of this set is equal to x is a natural number and not a perfect cube. And next one, this is 8th one. Here x such that x plus 5 is equal to 8. If you solve this equation, x is equal to 8 minus 5, that is equal to 3. Only one element. A contains only one element. If you exclude that element 3 from this universal set natural numbers, so you have to write the complement of this set is equal to x such that x belongs to n And here x does not belongs to 3. Only it does not belongs to 3. And similarly, if you solve this equation, the next problem, 2x plus 5 is equal to 9. So here, so here 2x is equal to 9 minus 5, that is equal to 4. So x is equal to 2. So only you have to exclude 2, only element. So the complement of this set is equal to x belongs to n, and x does not belongs to 2. X does not equal to 2. Here x does not equal to 3. And in the next one, here x such that x is greater than or equal to 7. So greater than or equal to 7, the numbers are 7, 8, 9, etc. So if you exclude all the numbers which are greater than or equal to 7 from the universal set, you will get only these numbers 1, 2, 3, 4, 5, 6. So you can write the complement of set K is equal to x such that x belongs to capital N and x is less than 7. So these numbers are x is less than 7. And next one, here x belongs to n and 2x plus 1 is greater than 10. If you solve this equation, 2x is greater than 10 minus 1, then 2x is greater than 9, x is greater than 9 by 2. So here x is greater than 9 by 2, the complement of this set is equal to x is less than or equal to 9 by 2. It is this element is greater than 9 by 2, so less than or equal to 9 by 2, all the numbers are in this set, the complement of this set. This is fourth problem. Here AB sets are given and the universal set is also given. And we have to verify the first one is complement of A union B is equal to intersection of their complements. So first to write the universal set and A set and B set. So here all the elements 2, 4, 6, 8 are here also in the universal set 2, 4, 6, 8 and 2, 3, 5, 7 and 2, 3, 5, 7. So these are the elements of universal set. And first, you have to find the complement of A union B. So first find A union B, that is equal to write all the elements of A and B. Those are 2, 3, 4, 5, 6, 7, 8. So right here, then complement of A union B is equal to the difference of universal set and A union B. So you have to exclude the elements of A union B from universal set. So 2, 3, 4, 5, 6, 7, 8. You have to exclude these elements 2, 3, 4, 5, 6, 7, 8. Then the remaining are only 1 and 9. So right here 1 and 9. These are the elements of the complement of A union B. And next you have to verify that this one is equal to the intersection of their complements. So first find the complement of A. So you have to find the difference of universal set and A. So you have to exclude these elements 2, 4, 6, 8. Remaining elements you have to write. These are the complement of A. Similarly, you have to find the complement of B. Here, those are 1, 4, 6, 8, 9. So you have to exclude these elements 2, 3, 5, 7. Then intersection of these two sets is equal to, here see the common elements are only 1, 9. So right here 1, 9. From 1 and 2, you can say that the complement of A union B is equal to the intersection of their complements. So from 1 and 2, the complement of A union B is equal to the intersection of their complements, hence verified. Next one is you have to verify the complement of A intersection B is equal to the union of their complements. So first find the intersection of A intersection B, the intersection of A and B. So the intersection of A and B. So you can see here A and B set. So only one element is common. So 2 is the common element. So A intersection B is equal to 2. And next one, intersection B is equal to, the complement of A intersection B is equal to, you have to exclude this element from the universal set. The remaining are 1, 3, 4, 5, 6, 7, 8, 9. And now you have to union their complements. So their complements, if you union their complements, these are their complements. So if you union these two sets, then you will get 1, 3, 4, 5, 6, 7, 8, 9, excluding 2. So these are the union of their complements 1, 3, 4, 5, 6, 7, 8, 9. So excluding 2. From 1 and 2, the complement of A intersection B is equal to the union of their complements, hence verified. And next one is fifth one. Here, draw appropriate Venn diagram for each of the following. The first one is the complement of A union B. So this is A set and this is B set. A union B, this is A union B. So the complement of A union B is the difference of universal set and A union B. So that means you have to exclude the part of A union B. So this is A union B. So you have to exclude this part. So the remaining this one is the complement of A union B. And next one is the intersection of their complements. You can see with this example also here. And this is the intersection of their complements. So here this is A set and this is B set. First find the complement of A. So complement of A is here excluding the A part, and complement of B is excluding the B part. So intersection of their complements is the common elements of these two sets. So that is for example, if you see here, this is 4, 5. So this is the part of intersection of their complements. So you have to show like this. These two values are equal. See here from this, these two are equal. And next one is the complement of A intersection B. So the complement of A intersection B. First to find the A intersection B. So that is, this is A and this is B. So A intersection B is this part. This is the common elements of A and B. So if you exclude this part, the remaining everything is the complement of A intersection B, because you have to exclude A intersection B from universal set. So you have to exclude only this part. So you can see from this example. Similarly, you can write first the complement of A is this part and complement of B is this part. And if you union that, you will get the full part excluding this part. You can see from this example. This is sixth question. Let U be the set of all triangles in a plane if A is the set of all triangles with at least one angle different from 60 degrees. What is the complement of A? So here given universal set is equal to set of all triangles, and A set is given set of all triangles with at least one angle different from 60 degrees. That means it is not 60 degrees. So here the complement of A is equal to set of all triangles with all angles 60 degrees. Here with at least one angle different from 60 degrees. So here with all angles 60 degrees. That means all angles are 60 degrees means that is an equilateral triangle. We know that in an equilateral triangle, all angles are 60 degrees. So the complement of A here is set of equilateral triangles. And this is seventh one. Fill in the blanks to make each of the following a true statement. So the first one is A union complement of A. That is equal to universal set. If you see the properties of this complement set, here you can see from this example. So here A union, the complement of A is equal to the universal set. And so directly you can write this one. And next one is the complement of an empty set intersecting the complement of an empty set, and A is equal to A. Because we know that the complement of an empty set is equal to universal set. You can see this also from here, the properties. See here, the complement of an empty set is equal to universal set. Here you can see with this example. U minus an empty set, because here only the elements of U. So this is equal to U, that is universal set. So the complement of an empty set intersect A is equal to, this is universal set intersecting A. That is equal to, because here the common elements are only A elements, that is equal to A. So the answer here is A. And third one, A intersect the complement of A is equal to an empty set. This also you can see from this properties. Yes, see here with this example you can see. So that is always an empty set. And next one is The complement of U intersects A is equal to an empty set, because the complement of U is equal to an empty set. Also, you can see here the complement of U is equal to an empty set. You can see here U minus U, that is an empty set. So this is an empty set. So here empty set intersects A is equal to always an empty set, because there are no common elements here. So that is an empty set. These are the answers here. Now please do these practice questions. These are the answers.